Hello and welcome back to Compiler Programming. Today I wanted to work on the cross-platform support of the compiler, and in particular, right now there is no real way to write code that calls platform-specific system APIs. So I have this process module that has a single function exit for now, so just so that I can exit the program, but this code is only working obviously on Windows because it relies on the kernel 32DLL. And the reason I postpone this is because it is not exactly clear how platform-specific code is supposed to work. The troubling thing for this compiler is that we don't isolate modules per target. So imagine that I'm running my compiler on Windows as I do right now, and then I want to cross-compile the code to Linux, right? So the question is, how can it select syscalls between Windows and Linux? If I just define something at the top level like this, then it will bind to whatever is the host version, and when you will try to call it runtime, that's not gonna work. So I was struggling quite a bit with how I want this to behave, and I think my solution right now is to just sort of force all platform-specific code, even if it is like if it's just static data, to force it to live inside functions, so that you have to write something like this. So if I don't know what would be good way to interact with it. Well, let's just say if get target OS is well, we don't have nice anonymous enums as well, so that's going to be a bit awkward. Let's just say, let's just figure out a good API. So we'd say OS. No, I think I like get target OS is OS dot Win32 or something. Maybe something like this. So then we do this stuff. Otherwise, we do whatever we will do for Linux, which will need syscalls. And I think even sort of the definition of this should live in here, maybe. Or maybe I would get a separate module for Win32 API. Okay, let's start actually with that. So we will go to st, we will create Win32. And in Win32, we'll just say that we will export exit process. And this is what it's going to be. Right? And then in here, we'll just say that Win32 is import of standard Win32. And then we would say Win32 exit process of status. I think something like this can work because I would like to organize the standard library by the functionality rather than operating system, right? Which is pretty standard in any language. But for the sort of definitions of library code, I think it's actually easier to to have it inside a module specific to the operating system. So we'll have standard Linux, and it's just gonna be the Linux stuff, which we can also create. Linux. Okay, and we can even create here what we want. So this would be syscall exit, and I can probably figure out what it should be. Okay, so this is how we write the syscall, right? Maybe I don't even need to call it syscall. Yeah, I don't think I do, to be honest. So let's uncomment this. Slash ends in here either. Kinda. We need one here. Well, no, not really. We don't even need this one. We'll just call it exit. And that's gonna be that. Now that we need to define these kind of constants, but they don't even need to be exported, which is good. And we can already see sort of encapsulation a bit. I think the stdout file number we do need to export. So let's do it like this. I think it's easier to copy here. Okay. Don't want to export that stuff. Okay. This is going to be syswrite. So that's actually write call. We can define it already. And then we can do exit. So I assume that's going to be status, but I have no idea what is the right stuff here. So let's check it out. Sys write. Okay, Linux syscall exit or something. Exit 2. Terminates process, blah, blah, blah. So it's not, yeah, right. In Linux, you send the sick child. Sick child, is it? Signal process immediately. Can I like look at what this actually does? Okay, Linux assembly exit process. I'm not a Linux guy at all. Kind of see me just Googling a bunch of stuff here. Yeah, but I don't want to call. So this is 32-bit. EX60 Linux syscall table. This is what I want. Okay. Is there something like exit? Oh yes. Okay. So there is sys exit, and you just do 60. Okay. Gotcha. So that's what we want. Sys exit 60 and sys exit. Okay. So for now we can just do it this way, and that should not change anything. I hope. But we will see if our nested imports are working. Okay. Everything seems to be working okay so far. Oops. Now our job is to just implement this get target OS and figure out what goes here. I'm still not sure if that is a great API, but oh, I don't know. It's fine. Let's just sort of try to do something like that. How would we go about that? I guess we can start with the enum, and we'll just look for an enum here. Doesn't matter what it is, but let's put it next to program, I guess, because that's where we will eventually show it. Okay, so we'll call it OS. That's gonna be Win32. I guess for keeping with the naming convention, I should just call it that. So we'll have Win32 Linux and OS X. I guess it's called macOS now. Yeah. Well, let's keep it this way, and then we will figure it out. Okay. But then it should be actually macOS probably, or even like this. Did you just call them Windows? I'll just gonna call it Windows. I know it's technically Win32 and Win64 or whatever, but we only support 64-bit anyway. I think this is fine. This is way more readable than anything else we had. So this is good. We are going to export it. Let's just I guess we can export it to the compiler. That's fine. And then we would go into here, and somewhere here we would say what? We would say OS is mass OS. Something along these lines. So then we can go in here and we can say, oh, for now, Windows. I still haven't figured out exactly what I want as a calling convention, or sorry, not calling convention, naming convention for enums and such. Like, should this be uppercase OS? Whatever. This is fine. Is it OS Windows? And we can just do this, I guess. And it still should. Actually, no, it won't. Yeah. So it is pretty unhappy about what? Do it this way. I just want a dummy condition, and right now the boolean now is yeah, it's a separate type. So anyhow, okay, so that works. We now have exported correctly the enum, but we do need to compare it with something. So for that, we need to store this OS somewhere, and I will just shove it in here on the program, which is an instruct that I use to kind of refer to things that are specific to the execution environment code is running in. So this tells it whether this is a JIT run or now it's gonna also have an operating system, right? So this is where it will live. We do need to put it there. So program init. Actually, I need to check if I don't call it somewhere else. Fine. It's fine. Yeah, okay. So it looks like I only call it here, which is good. Because then I can figure it out. So why we want to have this program init? What does it do? It's defined in program.h and program.c. Yeah, right. I do want to have this. Okay. Well then, I guess we need to pass OS here and add it in here. Like OS should also probably change what calling convention we are using, but let's just take one step at a time. Yeah, right. You unhappy about the fact that now you have padding. So U32 padding. I set it up to have explicit padding here because that makes it so that I can mem compare structs, and also I'm more conscious about the fact that I'm wasting space. So every time I have something unaligned, I have to insert an explicit padding stuff here, which actually might cause problems later on when we deal with this code in the userland in mass. But let's see how it goes. Okay, so this is here. We now need to pass something into here. So target calling convention, right? Well, right now they're all sort of, we don't support cross compilation, so for now I'll just do this. OS is OS Windows, and then I'll do to do allow to specify different. Okay, let's just do attack, say cross compilation. Okay, cross compilation, and then we need to do a bunch of ifdefs. So we have this post calling convention, which is defined in here as well. So let's look at that. Yeah, so That's basically what we need to do. If define blah blah blah, then we return OS Windows. We need to split these two, and I think I need to do it this way. Okay, then we say that that's OS Mac and OS Linux. OS enum variant for this host system. Okay. So we could probably then just do this hostOS and pass it in both cases. Okay, OS. Now I might actually be sort of supporting cross compilation partially right now on Linux to Windows. So that's gonna be broken, I guess, but it's fine. It is fine. I will fix it later. Now we'll just say OS. Just making progress. Okay, so that again shouldn't change anything, but doesn't hurt to check. We still can compile here. We can still probably compile here, I hope. Okay, great. So everything still works, but now we need to actually extract it somehow. And for that, we are going to write an intrinsic, but we will try to do it in the userland instead of in the core of the compiler. And we're gonna put it here. We are gonna say get target OS. Do I even need to say target? I guess let's call it get target OS. It's fine. So what is this thing? That is gonna be a function that will return us an operating system. It's, as I said, an intrinsic. And what intrinsic means is that I have access to the internals of the internal things in the compiler. And that should allow me to do funky stuff. So I can do intrinsic here. And how that look like? Just trying to find some code to copy paste. I guess this would be a good thing to copy paste. Get rid of the quotes. Let's get rid of /ends. And this is good. So we can say that we will return an OS. It's a bit size, U32. And here we will just say cast U32 from OS from context program OS. This. That should be basically what we need to do, but we'll see if that actually works out like I would want. The intrinsic stuff is still a bit finicky, like it's super powerful, but it stresses compiler to the maximum because It's all kinds of stuff, like this code is JIT compiled and it is immediately executed, and like in certain cases pointers are adjusted and all of this kind of jazz. So it might not work, but it might also work just fine. We will find out in a second. So that seems fine. Get target to S, process. Well, in a sense, that is the moment of truth. This should still work. And it does not. So, right. Do I define it? Generated. Where is it here? Define enum. Yeah. Okay, so it's underscore type. So it is like so, which is a bit annoying, but whatever. I definitely need to figure out a better answer for how enum's supposed to work before I go too much into implementation of other stuff. Field win32 does not exist on type scope. Yes, because now it's called Windows. Let's try again. And this is where we are, starting to run into these fancy things. A storage memory tag is B storage memory tag. Okay. Not exactly sure what's that about. Let's try to look in the debugger and see what it will tell us. Okay, handle generic comparison. Value is non-lazy static of left hand side. What is left hand side? Left side is descriptor OS, a pack. So it is a U8 for whatever reason. I wonder why that is. I guess because it looked at the value and decided that U8 is the right choice instead of looking at the bit size. Yeah, that's not cool. Not cool at all. And right hand size is correct. It's actually broken. And it's also broken in tests. So this needs to be tag is static tag or something like this, and then two. Is it called static memory? Yeah, it is. So static memory tag E32. Okay, let's try that again. Here we go. Okay, that is very cool. So that seems to work. Obviously, that code that needs some cleaning up. I also don't like this OS type thing that I have to do, which is I just really need to think about it. I was postponing as much as I could how to deal with enums, but I guess it is the time has coming to actually make a decision and stick with it and have something better than whatever this is. Okay. So anyhow, this is pretty cool for Windows. Now the question is, does that work for Linux? Well, it didn't break any previous test, but that's because none of those tests were actually calling this. I could just do a single test, I guess, but I think I want to transition Hello World to this stuff as well. So how would that look like? So I want to have like something like native write, which is going to be a function. And that function is going to take, what is it going to take? It is some kind of handle, but this is actually awkward because I think that Linux, oh no, it also uses 32-bit handle, so that's fine. Great, so that's a handle here. And then it will take the buffer, which is, yeah, pointer to U8, and it will take the size. In Linux, size is U64, and I think U64 is a better choice for this. And then I will cast it to whatever it needs to be. Right? It does not return anything, but let's be explicit about that. Actually, it kind of does, but I rather say that no, it doesn't return anything. Okay. And in here we can copy this stuff, what we did for the process, and it's sort of the same situation. And we would have write file in here, and like so. Now the cached handle thing is yucky. So I'm just gonna remove this thing and say to do figure out how to do it. OS support. So for now, we're just gonna do this. That's not great, but it's fine. This is an buffered write call, and it's okay if it's not the fastest thing in the world, and right now the speed doesn't even matter that much anyway. So that seems fine. Maybe I'll just do handle this handle, and then just use handle, and we'll put here buffer, and here we put size. Written or overlapped, that's okay. And in Linux, that's gonna be, actually, this should be called Linux. And here as well, Linux exit of status. Okay, and here was gonna be Linux dot. Maybe I should call it syswrite after all. And it's sort of the same situation, except size is what we expect it to be. Okay. That looks good to me. The only thing is we need to move these two functions to Win32 and export them. Looks good to me. See if that all still works on, actually no, yeah, that's gonna explode. Because write file in there, it's because of this print macro. So I want native write of string bytes, this stuff and this stuff. This is what I want. Let's see. Okay, now it's fine matching. Okay. We're gonna do it that way. And then in Linux, I need to say Linux dot, what is it called? stdout file number. Like this. So then it doesn't need the handle here. Let's try again. Okay, could not find matching call. Right, because in here I don't need to do the cast, that's just the Windows thing. Technically you don't need to recompile the code itself, but since we're not touching the compiler, that's fine. Okay, undefined variable write file. That is better because here it is calling it. So we are just going to say native stdout buffer and output size. It's output size to make it U64. And let's see how that works out. Call output size minus integer index. Right. So I do need to cast here. Right now I don't have minus defined for unsigned types, and I think I might keep it that way. Let's see how annoying it is in practice, but I had a bunch of issues writing code where it would just silently overflow. Maybe that is the better thing to fix. I don't know. Let's see. Okay, here we go. That is pretty cool. I like this refactoring. And now the question is, with all of this in place, can we run FizzBuzz on Linux? Well, first of all, let's run everything else besides FizzBuzz on Linux, and then go from there. And we are dead. It's interesting. I wonder which code is causing this exactly. Okay, so it's not here. I'm guessing it is this one, but it's also a bit unclear if that is the case. That sort of has nothing to do with the problem that we are trying to solve right now. It's kind of annoying that it is cropping up in this case. So I think what I might want to do, instead of diving deep into this whole register allocation situation, I might try to just take some test that would test this and just keep it that way. So where are we crashing? We are crashing at P32 executables. That's fine. Where do we have hello world? Script mode. I mean, that should technically work. Okay, great. So the code that we just wrote actually works. As I said, this is a problem deeper in the compiler somewhere, which I don't want to look into right now. But the actual selection of stuff is working perfectly. So if we look at that script file, it does what we basically would expect it to do. It does IO print, and it doesn't do sysexit because it is done for it automatically, which is part of the nice thing about the script mode. So I guess that means that we should be able to actually run it from the command line, which should be pretty cool. We do fixtures, script mode. Let's see. And we have hello world. This is amazing. So this is nice. I think once the language is a bit more stable, I will just transition all my bet and sh files to this stuff, because I think that's going to be very, very nice. Okay, I think that will be all for today. I will now put on my debugging hat and spend a few hours probably trying to figure this out, because it's usually pretty nasty to detect, but I did what I wanted to do today. It works pretty nicely. I'm very happy that it worked out so well, and it also gave me some more things to do, as said, like cleaning this up, cleaning the enums up, and obviously fixing this issue. But all of that will happen probably offline. For now, I thank you very much for sticking with me, and hopefully see you next time.